Well, I think, so we're looking at special homework number 6, number
Yeah.
1. I think in class, didn't we prove, um, this one says if X and Y are rational,
And then 2x plus 3y is rational. Oh, okay.
yeah, then 2X plus 3Y, is rational. But didn't we prove that the sum of two rationals is rational in class? Didn't we prove this? If
Yeah,
X
yeah, we did that thing. Yeah.
and Y are rational, then X plus Y is rational. It's a lot like it's a lot like that, right? The only
Mm.
difference is we have these two
So,
coefficients,
yeah.
2 and 3. So, if you start writing your proof, and then you use the definition of rational applied to X, and you use the definition of rational applied to Y, right?
Mm.
You're going to still have these same definitions, right? And instead of looking at X plus Y, because when we looked at X plus Y, it was A over B plus C over D, right? And
Mm.
that was AD plus BC over BD. Just imagine that it's 2X plus 3Y. So it's 2A over B
Mm.
plus
Yeah.
3C over D. So the only difference is you've got, these coefficients as factors of these two terms in the numerator. See what I mean?
Yeah.
That's the only difference between those.
Oh, I got it now. Thank you.
You're welcome. Anything else?
Hmm. No, that's it. The other one I can't do it, I think. So,
Cool.
yeah. Thank you.
You're welcome. Have a good night.
You too.
So we worked a very similar problem in class.
Mhm.
All right, so in class we worked if X and Y are rational, then X plus Y is rational. Do you remember that?
Yeah, I remember that.
All right, so we get our,
A,
we
B, C,
start
D.
the
Yeah,
proof and,
yeah,
assume X and Y are rational, all that good stuff. And by the definition of rational, we write X and Y like this.
yep. A,
Now,
A, B over
yeah,
C, D.
and
Yeah,
what we had was X plus Y equals A over B plus C over D, and then we use our algebra and we got that.
yeah.
Right?
Yeah.
All you got to do is stick a 2 in front of the X
Really?
and a
Okay.
3 in front of the Y.
Then you put it for A
All
and
right.
C.
And then there's a 2 here and a 3 here. So
Yeah.
there's a 2 here and a 3 there.
Oh,
And then you just got to talk about this being an integer, talk about this being an integer, and then explain why that's not 0.
okay. 100%.
So it's just like what we did in
Just
class,
like what we did. All
except
right.
we have these extra factors, 2 and 3 in the
Okay.
appropriate places. Okay.
Okay. I saw it and I was going through and making sure double checking my work and I went, I don't where did I put the two at?
Yeah, yeah.
And
Where do you
then
put the 2 at? It goes upstairs with the A.
and not at the bottom. Perfect. That
Well,
makes
yeah,
sense.
yeah, because otherwise it would be 1/2. Like 1/2 X would be A over
Yeah, yeah.
2B. But 2
Okay.
is really 2 over 1, right? We don't really,
Yeah.
I mean, it's really, 2 over 1 times X over 1, right?
Yeah. Okay, good. Because that's the only question I really had.
Okay.
Like, I should be back for the rest of the night. I understand the rest though. So
Oh, I'll be here for another 14 minutes. All
okay. All right, I'll see you.
right, all
Thank
right,
you.
bye. Start recording again. What can I do for you?
Nah, I thought somebody was I thought people were in here. I just
Well, there's people asking about problem number 1.
oh in the homework.
Yeah,
Yeah, can we go over that? I mean, we
yeah,
already
yeah,
went over
sure.
that, but
All right, so remember in class, we proved this. we proved if X and Y are rational, then X plus Y is rational. Remember that? You look at the notes, we have a proof of that. And, we start the proof and we say, assume X and Y are rational. We wish to show this is rational. Well, the difference here is we wish to show 2X plus 3Y is rational, okay? So we break out the definition of rational, right? X is A over B, Y is C over D, A and B are integers, C and D are integers, and B and D aren't zero, right? Now, what we did in class was, if you look at the notes, we were just proving that X plus Y is rational. So, we just looked at X plus Y. I'm going to clean this up so I can show it to you. Okay, so what we did is we say, okay, we're looking at X plus Y. So X plus Y equals A over B plus C over D, and it turned out to equal AD plus BC over BD, remember?
Yeah.
But the only difference now is it's 2X plus 3Y, okay? Well, that just puts a 2 up here with the A and a 3 up here with the C. And so that just makes this 2AD, 2AD plus 3BC. So now we just talk about, this whole thing is an integer. Products and sums of integers are integers. This whole thing is an integer because products of integers are integers. And then you talk about the bottom not being zero. So it's a lot like what we did in class. It just has these extra factors of 2 because it's 2X and 3 because it's 3Y. That's all.
Okay.
Does that make sense?
Yeah. Yeah.
Anything else?
Uh, to be honest, I came in here just to see what people were doing, but yeah,
This is
that makes it clear for number
this is
one.
the main one people have been asking about. Yeah. I
Yeah,
mean, it's
it
the
makes
only one people have been asking about. I guess people are just now getting started on the home.
Yeah, I thought it was due on like Wednesdays, like when it usually
No,
is.
it's actually due tomorrow.
Yeah, I know now.
Now, I sent out an announcement. I sent out an announcement on either Wednesday night or Thursday morning saying, "Oh, my bad. It's actually you gotta get it to me on Monday because we gotta move ahead. We got stuff to do."
Yeah, that makes sense.
Did you even look at number 2 yet?
I'm looking at it right
Yeah,
now.
let's look at number 2. It says, if A divides B and B divides C, then A squared divides B squared plus C squared. Now we did, a bunch of these in class. But, you just got to assume that A divides B and B divides C because that's our hypothesis. And then you wish to show that A squared divides B squared plus C squared. So you got to break out the definition of divides and use it twice. Once because A divides B, and again because B divides C. Then you get your equations for B and for C. And then you got to get an equation that shows B squared plus C squared equals A squared times some integer M. Remember the definition of divides? X divides Y means Y is equal to X times K, where K is an integer. That's the definition that you've got to be using, the definition of divides.
Okay.
So that, like I said, in the class notes, we did a bunch of these. And we did one, where it was A divides B and B divides C. We did do one like that. And we also did one that had, some powers. So you should be able to put the pieces together from the example shown in class.
Yep, this one, yeah, this one's pretty easy because we've done a lot of these.
Yeah, and there's really nothing hard about the one with rationals either.
Nah, it was just tricky. I just didn't know. I don't
What to
know.
do with the two and the three?
Yeah,
Well, that's the deal, they're just upstairs here, because two is really two over one. So this is, really a 2A over 1 times B, but we don't even write the 1. Because 2x is really 2 over 1 times x over 1. But x is A over B.
yeah, that makes sense. Well, thanks for the pointers.
You're welcome. Thanks for coming in. Thanks for stopping by.
Yeah, no problem. Have a good night.
You too.